Welcome. Today we are doing angles and radian measure day 2 and 3. And we're going to start off with what we call the unit circle, which will show us the degree and radian measures of angles that you would commonly see in trigonometry. So I'm going to show you how to draw each angle in standard position. And the initial side, that means the side that we start with, will always start on the positive x-axis. So that means here. And anytime our angles are positive, we're going to go counterclockwise. That means this way. And here's my y-axis. So our unit circle, and if you notice, with this coordinate plane, it is divided into 4 quadrants, and we count them 1, 2, 3, 4. Because sometimes they may ask you, not only are you going to have to draw the angle in standard position, but you also have to label which quadrant it's in. Okay. So, let's go over the unit circle. I'm going to attempt to draw this circle. And then, it's probably easier when you're drawing the angles to divide the rectangular coordinate into 8 equal sectors. So it'll look something like this. Okay, which means that now we've made this is 1/8 of a revolution. Remember, revolution is 2 pi radians. So if you do 1/8 of 2 pi, you're going to get pi over 4. And if you go all the way around the circle, counting, that's 1 pi over 4. This is 2 pi over 4, but that has to be reduced. 3 pi over 4. 4 pi over 4, which is 1. 5 pi over 4 would go here. 6 pi over 4, but we have to reduce it. You notice each time I'm reducing it. 7 pi over 4. And then 8 pi over 4, which would be 2 pi. Which is also our starting point at 0. So 0, 2 pi, they both start at the initial side here. Now, if we wanted to do these in degrees, since we were doing in eighths, 1/8 of 360 is 45 degrees. So this is 45 degrees, 90. When I mean that, that means here, from here to here. That's a 9-degree angle. This would be 135. So that means you would have to start here and go all the way around. That would be 135. Then we are at 180. Remember, we learned 1 pi radians is 180 degrees. Then this will be 225. This is 270. And then here would be 315. And we'll be back at 360 degrees. And then we're going to cut our circle into 12 equal sectors. So it can look like this. So 1/12 of a revolution, or 1/12 of 2 pi, would be 1 pi over 6. 1 pi over 6, 2 pi over 6. This would be 3 pi over 6, which we already have. 4 pi over 6. 5 pi over 6. 6 pi over 6 we already have. 7 pi over 6. 8. Okay, now we're going to look at drawing angles in standard position. So I'm going to draw the unit circle back with my coordinate plane. And don't forget the quadrants. They go 1, 2, 3, 4. And just remember, our initial side starts here. And if it's a positive angle, we go counterclockwise. So you would go in this direction. If it's a negative angle, we would go clockwise. So you go in this direction. So let's say they wanted us to draw negative 30 degrees. Let me move this. So I'm going to go ahead and divide this up. This is how you would divide each quadrant. And so our initial side will start here. And we're only going negative 30. Remember, 1/12 of a revolution, or 1/12 of 360 is 30. So you would stop here. You always start at this initial side. And remember, 30 degrees is the same thing as pi over 6, because that's 1/12 of 2 pi radians, which is pi over 6. But since we went negative, that would be a negative pi over 6. Now, what's interesting is if we went counterclockwise to end up at this same point, going in this direction, that puts us at, if you notice, we made a complete revolution. So you think about how much more do you need to make a revolution? Well, one revolution is 360. So if we've already done 30, but going in the opposite direction, then that means that this angle, the green, had to be 330. And so if you take the difference of 330 minus negative 30, you would get 360. So going in the clockwise, on a counterclockwise position, that would put us at 11 pi over 6. So these two angles have the same terminal side. And if you notice, both these angles are in quadrant 4. Now, what happens if you have an angle that is more than your one complete revolution? If they wanted us to draw, let's not use that color. They wanted us to draw 9 pi over 4 in standard position. When you guys draw in standard position, you always want to show your coordinate plane. So we know that when you're going around the circle, and I always think about it, if you remember we were doing in fourths, that means that we had to cut our circle into 8 equal sectors. So it was like this. And when we counted, this was 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which I'm going to reduce, 7 pi over 4, and then we'll have 2 pi. So there's two ways you can do this. You can keep counting around until you get to 9 pi over 4. So it'll look like this. After 8 pi over 4, then it'll be 9 pi over 4. So you'll start here. You go all the way around. So that was 8 pi over 4. This will be 9 pi over 4. Or you can figure out how many times 8 divides into 9. So this will be like, because remember it was in eighths. So you can, so this would be 1. Oh, let me change my color. It'll be 1 and 1/8 of a rotation. So we would have to go 1 full rotation and then 1 more eighth to make it 9 pi over 4. So it's like doing 9/8 times 2 pi, which would be 1 revolution. So you could look at it like that, or you can continue to count around until you get to 9 pi over 4. So since this is a circle keeps going and it doesn't end. Now we're going to draw 13 pi over 4. Since we're in fourths, cut my circle into 8 equal parts. So this will be 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi. Alright, I now have to do 13 pi over 4. And like I said before, if you want, you could just keep counting. Because remember we stopped at 8 pi over 4. So I'll do this. So this will be 9 pi over 4, 10 pi over 4, but you always have to reduce it, 11 pi over 4, 12 pi over 4, which now would be 3 pi, and now this would be 13 pi over 4. So we went around 1 full time, and then we had to come back around and stop right here. Another way you can do it is how we did it previously, is 13 pi over 4, and then all you have to do is figure out how many eighths that is. So that would be 13/8 of a revolution, or 1 5/8 of a revolution. That means that you would go around 1 full time, That'll be 1 full time. And then you would need 5 more eighths. 1, 2, 3, 4, 5. So that's another way you can find it out. And you would do the same thing if it's a negative angle. You would just now count clockwise. So everything would be in the opposite order. For example, if they want us to draw negative 7 pi over 4, sorry about that. I'm going to do my eighths again. So if you notice, anytime we're in fourths, you got to cut your circle into 8 equal parts. 1 power 4, 2 power 4, 3, 4, 5, 6, 7, 8. Oh, 2 pi. Now, be careful because, which is the same thing as 0. I keep forgetting. This says that we are drawing negative 7 pi over 4. This does not mean that we're just going to go here and stop. Because remember, this is only 1/8 of a revolution going in the opposite direction. 1/8 of a revolution is only 45 degrees. And remember, if we're counting this way, we've done 1, 2, 3, 4, 5, 6, 7 eighths of a revolution. That's 7/8 times 2 pi, or 7/8 times 360. That's 315 degrees. So we can't, if we're trying to draw negative 7 pi over 4, that means we need to go a negative 315 degrees. So we would start here, but we would count 7/8 all the way here. So now that would be negative 7 pi over 4. 1, 2, 3, 4, 5, 6, 7, 7/8. Okay, so you have to be really careful about the negatives and going in the clockwise position. So that will conclude this lesson.